Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 6, and this problem asks us about what acid chloride will we need to prepare each of the following ketones from benzene using Friedel-Crafts acylation. So what we know about Friedel-Crafts acylation is that we have some sort of benzene ring, and using some sort of acyl halide, in this case we'll say acyl chloride, and this grouping R could be anything, and some sort of Lewis acid, we can get addition, or actually substitution, of this acyl group on our benzene ring. So this is a general mechanism. So essentially what happens is that we have the chlorine group leaving in this situation, forming a carbocation intermediate, which is our electrophile, and then we get some sort of electrophilic aromatic substitution using the benzene ring as our nucleophile, and this is our electrophile. So what we need to do is some sort of retrosynthetic analyses, and we know that we're starting off with benzene, and we know we're now forming a new bond between the ketone carbon, or the carbonyl carbon, and the benzene carbon. So we know that we need to break these bonds. And what we know is that when we break these bonds, the substituent that's attached to this carbonyl group is the chlorine atom. So we know that in order to add this acyl group to benzene, this acyl group must have the identity of chlorine, carbonyl, and then CCC 1, 2, 3, and then 2 carbons like that. So this one is the same thing. We know that now we have this is the R group of our acyl, and now we know that we're attaching this to benzene, but before we attach to the benzene, it must be a chlorine, which is going to leave through the mechanism of our Friedel-Crafts acylation. And same with this problem here. We have the cyclopentyl derived acyl group, and we know that we're adding it on the benzene ring, and actually we broke the wrong bond here. We are breaking this bond between the acyl group and the benzene, which we're adding it on, so this bond breaks.